Good morning, children. I think in the last class we studied about the formulas. I told you already. The singular form is formula and plural form is formula. So today we are going to study the main chapter in 10th standard, that is polynomials, which is very important. And these formulas are based on these chapters only. You may ask why you are starting with polynomials, because it is one of the best chapter in the sense more important for the exam purpose. And also we have, after this we have quadratic equation, and after this we have trigonometry also. So these are the scoring subjects where you need to be perfect. So let us start with the polynomials. Okay students, see, let us see what you mean by polynomials first. Polynomials, Polynomials. What do you mean by polynomials? This is chapter. If you take textbook part 2, in that the first chapter is the polynomials. So let us start. What do you mean by polynomials and what are the problems we have in polynomials? So how to work out these problems in polynomials? It is very easy. I told you to by heart those formulas. So if you are perfect with the formulas, then it will be very easy to follow the formula. Polynomials. Generally, if you go for English dictionary, means English dictionary in the sense exact meaning of polynomials means poly means many. Poly means what? Many. Nominals means it may be constants, it may be variables, it may be anything, whatever it is. So the totally means many terms will have, many variables will have, you will have many constants will have, and we have many things also in this chapter. So let us see what do you exactly mean by the definition of the polynomials. So the definition of the polynomials is an algebraic expression. Please copy down or write it down in your notes. An algebraic expression of the form. See, this definition exactly will not get in your textbooks. This is you have in textbook, but they are not meant in detail in the textbook. So write down, it is very important one. An algebraic expression in the form if you take P of x. What is P of x? P stands for polynomial, x stands for any variable or any number or any constants. So x may be anything. So that equals to a to the power of 0 plus a1x plus a2 x2 plus a3 x3. It goes as continuation until you get an to the power of x to the power of n, means in which the variables involved have only non-negative integral exponents is called a polynomial in X. So what do you mean by this thing? So I told you, any algebraic expression in the sense, any algebraic expression, the expression of the form, it should be in which form? It is a p of x, where p is a polynomial and x may be variable or any constant, and a to the power of 0 plus a1x plus a2x to the power of 2 plus a3x cube. It goes on an x to the power of n. And main important thing is here, in which the variables involved have only non-negative integral. Underline the word non-negative integral. What do you mean by non-negative integral? Here non-negative integral in the sense the power should not be a negative one. If the power is a negative one, then you will not call it as a polynomial again. I will give the examples, many examples I will give you, and let me know you what do you exactly mean by this. So in which the variables involved, what are the variables which are involved there, have only non-negative integral, means which is a positive one. So this is the special of maths. Instead of telling you the positive, he has used the word non-negative, means which is non-negative. Which is non-negative means which is a positive one. Non-negative integral exponents. I told you already what are exponents. If you see 2, 3, these are the exponents. 2 is exponent, 3 are the exponents. Is called a polynomial in x. So this is a polynomial in x. So copy this. This is the main definition of the polynomial. What is the main definition of the polynomial? Once again I will go through it. So an algebraic expression of the form p of x equals to a to the power of 0 plus a1x plus a1x1 plus a2x2 plus a3x3, and it goes on up to an x to the power of n, and where the variables involved have only non-negative integral. They should be only non-negative integral exponents. This is called a polynomial in x. Okay, copy there. Very important. This is what you mean by exactly the polynomial. So let us start with degree of polynomials. Take note. This is also very important. What do you mean by degree of polynomial? I will tell you what is degree of the polynomials here. So I will give you one table. If possible, copy the table also. There it is given very clear. I told you already these things are not in a textbook. If you go through it, it will be easy for you to understand the chapter which is in your textbook. So the table goes like this. Polynomial, and we have variable, and we have highest exponent. Copy this table also, because it is important. You will find it very easy to differentiate what do you mean by a polynomial. So what is a variable and which is the highest exponent in that polynomial. I already told you it should be a non-negative exponent. First let us see 5x plus 4. If you see 5x plus 4, in that which is variable? X is the variable, and the highest exponent is 1. Okay, see the variable is x here, so we return variable as x, and the highest exponent is 1. So means x to the power of nothing means it gives the meaning it is 1. And we have second one, 3y square plus 4y plus 1. So which is the variable now here? Here you have the variable x here, and now we have the variable y. So variable is y, and the highest exponent is, we have 1 here, here we have 2. Okay, the highest exponent 5x plus 4, the variable is x there, highest exponent is 1 there. So here 3y square, the variable is y, and the highest exponent is 2. Let us see another one. So which is the variable here? We can see the variable y here, and here we have the variable m. So m is the variable, and which is the highest exponent here? Here it was 1, it was 2, and it is 3. The highest exponent is 3 here. Okay, and the last one, plus 8. Now observe it very carefully. Which is the variable here? Here we have x, here we have y, here we have m, and here we have u. So the variable is here u, and what is the highest exponent here? In the beginning the exponent was 1, and the exponent was y, and the exponent was 3, and here the exponent is 4. So 4 is the highest exponent here. So now observe carefully here. I told you already, this is a polynomial. Got it? It is a variable, and it is the highest exponent. In this polynomial we have x as a variable, and the highest exponent is 1. In second, y is the variable, and highest exponent is 2. And in third we have m, which is a variable, and highest exponent is 3. And in the last one we have u, which is the variable, and the highest exponent is 4. So children, try to copy this table, because this table is very important for you, so that you can remember very easily. So we can write these in statements also. So I will write the statements also, copy the statements. How to read these polynomials there? So if I write the equation, the highest exponent, the highest exponent of the variable in the polynomial observe clearly here, the highest exponent of the variable in the polynomial is called degree. You see here, the highest exponent of the variable in the polynomial is called its degree. It is called a degree, or you may call it degree also. So let us see one example. Let us take the first example. That is, what is 5x plus 4 we are written there. So what is 5x plus 4, and what is the exponent, and how to read this statement? If we take 5x plus 4, then we can read it as the degree of polynomial the degree of polynomial of p of x. Why I am writing x here means here we have the variable as x here. So the degree of the polynomial of p of x equals to 5x plus 4 is 1. In the same way, we can write the second one also. What is the second one? In the second one we have the degree of polynomial p of y. Now why p of y? Because here we have y here. Last time we had x there, now we have y equals to, we have 3y square plus 4y plus 1 is 2. Here it is 1, here it is 2. This is how you have to read the polynomials. So this is the main thing which it is not there in your new textbook. Okay, no problem. So we are learning this here. So what is the degree of the polynomial? P of x is 5x plus 4. The degree is 1 here. And here the degree of polynomial P of y equals to 3y square plus 5y plus 1 is 2. So this is how to read the degree of the polynomial here. In the same way you can read all the polynomials. The degree of the polynomial P of m here. So we'll get there 3, and here the degree of the polynomial u, then you'll get there 4, because the highest exponent is 4. We have another polynomial which is called constant polynomial. What is constant polynomial then? When you call a polynomial as a constant, because we have seen the degree of 1, the degree of 2, the degree of 3, as well as the degree of 4, but here we have constant polynomial. What is constant polynomial? For example, if you take f of x equals to minus 10, or p of x equals to minus 2, or you can take plus 10 also, no problem, or g of x equals to 1 by 7, or h of y equals to 3 by 4. So these are called constant polynomials. Why you call them these as constant polynomials means, see, the f of x is 10 means the value of 10 doesn't changes at all. Yesterday I told you the difference between a constant and a polynomial. That's why I told you to go with the variables or constants, or you have to do the revision. If you don't do the revision, it is very difficult to understand the further subject. So yesterday I told you what do you mean by constant, and I also told you what do you mean by a variable. So here what is telling is 10 is a constant because the value of 10 doesn't change at all, and here minus 2 is there, so minus 2 will be always minus 2, and 1 by 7 is there, so it will be always minus 7, and 3 by 4 is there, it will be always 3 by 4. So the value doesn't change at any time, whether it is 10, whether it is minus 2, 1 by 7 or 3 by 4. So these type of constant where the value is exactly same, where the value doesn't changes, is called constant polynomials. That's why we call them as constant polynomials, and these are called constant polynomials also. And we have zero polynomial. What is zero polynomial? We have seen here constant polynomial. Now we have zero polynomial. So the value of the polynomial will be 0 in constant polynomials. For example, if you see the constant polynomial zero or f of x equals to 0 is called constant polynomial. So zero polynomial. So what is zero polynomial? So the constant polynomial 0, whether the value of the polynomial, if f of x is 0, then it is called zero polynomial. This you have to keep in mind. So we have many polynomials here. One, we discussed about constant polynomials, and second, we discussed about zero polynomials, and we discussed about our variables, and we discussed about where are constants and everything. Now let us go how many types of polynomials are there. Let us see types of polynomials. So for this I have one chart here. So let us go through the chart first. Let us see how many types of polynomials are there, and we'll have the examples also, and we have the general form also, and examples also. For example, the first polynomial is linear polynomial. It is called linear polynomial, or you can give the heading polynomial here. Polynomial, then degree, then general form, then we have examples. So in these types of polynomials, first one is linear polynomial. What is linear polynomial? So in linear polynomial, the degree will be always 1. You have to keep in mind, in linear polynomial, the degree will be always equals to 1, and its general formula is ax plus b. Okay, and you can see a is not equals to 0. Why is not equals to 0? I'll explain you afterwards. Just first write it down. Then example we have 4x plus 5. This is called linear polynomial. Let us go for second one. We have quadratic polynomial. And the degree is 2. General form is ax square plus bx plus c. Same thing where x is not equals to 0. A is not equals to 0. And the general form is 2x square minus 6x plus 5. And we have the third one. These three are very important for you, but if you go for higher classes, they will learn many more polynomials. For you, only 3 polynomials are given. First is linear polynomial, second one is quadratic polynomial, and the third one is cubic polynomial. and here the degree is 3, and the general formula is ax cube plus bx square plus cx plus d, where same thing a is not equals to 0. And you can give any examples here. X cube plus 2x square minus 4x plus 7. Now learn in detail what you mean by these polynomials. So I told you already it is the types of polynomials. So in the first we have polynomial. Heading is given as polynomial and its degree, general form, examples. In this the degrees and general forms are very important, because when you know the general forms exactly, then you can write any polynomial, whether it is a linear polynomial, whether it is a quadratic polynomial, or whether it is a cubic polynomial. Let us see what is first one. I told linear polynomial. Linear means in mathematically it is 1. So we have only one power, and the given example is 4x plus 5. And second one we have quadratic polynomial. Quadra means 2. Quadra indicates 2. So quadra means 2. So it is a quadratic polynomial and the degree is 2, and the general form is ax square plus bx plus c, and the example I have given is here 2x square minus 6x plus 5. And again we have third one. It is a cubic polynomial where the degree is 3, and we have general formula ax cube plus bx square plus cx plus d. See here we have here 1, here we have 2, here we have 3. Linear, quadra, cubic. Cubic means 3 sides. 3 sides means 3. The example is x cube plus 2x square minus 4x plus 7. So copy this table also. It is also very important table where you will know the polynomial, the name of the polynomial, and the degree of the polynomial, and the general form of the polynomial, and also what are the examples of the polynomial. He has given in detail. So copy this table also. Okay children. So on this basis, what you are seeing, a linear polynomial, quadratic polynomial, cubic polynomial. Let us solve 1 or 2 problems so that it will be easy for you to understand what you mean by these polynomials. So let us see what are the values of the polynomial. If you consider a polynomial f of x where it is given as 4x plus 5, so we have the value of the polynomial f of x equals to 4x plus 5. I will give the simple example. We don't go the big example. Afterwards we'll see the examples also. What happens if x equals to 1? What will be the value of the polynomial? Now you can observe clearly that the f of x changes to 1. Why? Because the value of x is here 1. So f of 1 equals to, what is 4? What is the value of x here? He has given 1. Simple thing. I think you have studied in 9th also. So f of 1 equals to 4 plus 5. So f of 1 equals, what is 4 plus 5? 9. This is one of the small example which I have given for linear polynomial. If we take a quadratic polynomial, then what will be the value of the quadratic polynomial? He has given g of y equals to, the first one linear, the second one quadratic polynomial. G of y equals to y square plus 3y plus y plus 5, and he has given if x equals to 2. Simple one, just we are finding the value of the polynomials. How to find the value of the polynomials? Using small numbers. Afterwards we'll go with the big numbers. Just he has given. Now the polynomial g of y changes to g of 2, that is equals to, what is the value of y here? We have what is the value of y? We are given value of y equals to 2. So it is 2 square plus 3 into, what is the value of y again here? 2 plus 5. So just substitute the value of y in the equation what he has given, in which polynomial he has given. So g of 2 will be 2 square is 4 plus 3 2 ja 6 plus 5. Now g of 2 equals to, what is 4 plus 6? 6 plus 4, 10. 10 plus 5, 15. So g of 2 equals to 15 when it is a quadratic polynomial. What happens if it is a cubic polynomial? Third one I'll write here. First, it is linear, example for linear. This is the example for quadra. This is example for cubic polynomial. So he has given f of x equals to x cube plus 2x square minus 3x plus 4. X cube plus 2x square minus 3x plus 4, where if x equals to minus 1. So how you will solve this problem? The simple one, same thing, substituting the values and going on explaining. So instead of x you will get minus 1. F of minus 1 equals to minus 1 whole cube plus 2 of minus 1 whole square, because the value of x is minus 1 here, minus 3 of minus 1 plus 4. You can observe here x equals to minus 1, so we are substituting the value of x as minus 1 in this equation. Correct? Now f of minus 1. What is minus 1 whole cube? I think you know the value of minus 1 whole cube, because if you say minus 1 whole cube equals to what? Then you will get minus 1 into minus 1 into minus 1. So it is nothing but minus into minus plus 1 into 1 is 1. Then again you have minus 1. Into minus 1. Again plus into minus is minus, 1 into 1 is 1. So again you get here minus 1 plus 2 of minus 1 whole square is 1, and we have minus into minus get plus, 3 into 1 is 3 plus 4. Now f of minus 1 equals to minus 1 plus 2. What is the value of minus 1 plus 2? It will be always 1, because if you subtract the greater sign you have to put 2 into 1 is 2 here, but after subtracting we will get 1 only. If you are getting confused, I will go it another way. See, minus 1 is there. Okay, keep minus 1 as it is, or else you will get confused. Plus 2 into 1 is 2, plus 3 into 4 is 7. F of minus 1 equals to, now you can see r minus 1 plus 7 plus 8, 9. F of minus 1 equals to 8. Got it? So this is how to solve the problems here. First one, it is linear. Second one, it is quadra. And third one, it is cubic. These are the values, how to find the values of the polynomials. So f of x is given, f of x equals to 1 is given here, and here it has given if y equals to 2, then here he has given if x equals to minus 1, if x equals to 1. So by substituting these values in the general form of the quadratic equation, you will get these values. Okay, copy the problems and try to do revision daily. Why? Because these problems are the basic structures. So now we will directly enter into the chapter polynomials. These are the basic things which I have studied already, but once again I want to make you to refresh it. So we will see what are the polynomials, how many types of polynomials in the next class. Thank you children for today itself.